Welcome to EDU World Space.
Right, so here's the problem 82 in chapter 19, and for this question, we're going to calculate the equilibrium pressure of CO2. So for this equation, K, the equilibrium constant, is just simply equal to the pressure of CO2, because the other two are solids. So in order to calculate delta G for the reaction, we will be using this formula, delta G0 equal to delta H0 minus T delta S0. And then we calculate the K and P of CO2. So delta H0 of this equation is equal to the delta H0 of the product, PbO solid, plus the delta H0 of CO2 gas, minus delta H0 of PbCO3 solid, and this is equal to negative 217.3 minus 393.5 plus 699.1, and that will give you a number of 88.3 kilojoules. And for delta S0, that is equal to the S0 of PbO solid plus S0 of CO2 gas minus S0 of PbCO3 solid. And this is equal to 68.7 plus 213.6 minus 131.0, which is equal to 151.3 joules per Kelvin. And if we convert that into kilojoules, that would be equal to 0.1513 kilojoules per Kelvin. All right, so now let's look at each conditions. Condition A, when the temperature is at 400 Celsius degree, this will be equal to 400 plus 273 Kelvin. So that is 673 Kelvin. So in this case, delta G0 is equal to delta H0 minus T delta S0. That is equal to the number of delta H0 is 88.3 kilojoules minus 673 Kelvin times 0.1513 kilojoules per Kelvin. And the result will be equal to negative 13.5 kilojoules. So if ln K is equal to negative delta G0 divided by RT, that will be equal to negative 13.525 times 10 to the third joules divided by R is equal to 8.314 joules per Kelvin times the temperature, which is 673 Kelvin. This will be equal to 2.42. So K value will be equal to the pressure of CO2, and that will be about 11.2 atmosphere. Part B, delta G0 equal to delta H0 minus T delta S0. And the temperature is at 180 Celsius degree plus 273. That is equal to 453 Kelvin. So in this case, delta G equal to 88.3 kilojoules minus 453 Kelvin times 0.1513 kilojoules per Kelvin, and this will be equal to 19.8 kilojoules. So once again, ln K equal to minus delta G, 0 divided by RT. This is equal to negative 19.8 kilojoules times 10 to the third joules per kilojoules. So this is only changing the unit from kilojoules to joules. And then R is equal to 8.314 joules per Kelvin times the temperature, which is 453 Kelvin. And you will get a number of negative 5.25. So this is the value of ln K. We need to solve for K. So if we solve the number for K, that is equal to the pressure of CO2, and the value will be 5.3 times 10 to the negative 3 atmosphere.